Hello everyone, I am Sujani, Faculty in Physics at Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about photodetectors or photodiode. Now let us see the brief outline of this topic, photodetectors, how we are going to discuss about this. First we'll see the introduction for photodetectors, and we will discuss in detail about the construction of the photodiode, and then comes the working of the photodiode. We will see the working principle and how a photodiode works. And then we will understand the characteristics of a photodiode by seeing or by plotting the graph for V versus I, voltage versus current. Then we'll discuss the advantages as well as disadvantages of photodiode. And finally, we'll see the applications of photodiode. So first, coming to the definition, what is a photodiode? It is a special type of PN junction device which generates current when exposed to light. That is why it has got the name photodiode. So what is it? It is a PN junction device, but it is specially made. We will see how in the construction what is special about this PN junction diode, how it behaves as a photodiode. So what happens here is it is generating current when exposed to light. This term is very important. We are taking a photodiode, and when this photodiode is exposed to light, current is generated. So we call it as photodiode. It is also known as photodetector or photosensor. So all these terms are synonymous. When we say photodetector or photosensor, it is nothing but a photodiode. And it operates in reverse bias mode. What is this reverse bias mode? When we have discussed about PN junction, we have discussed both the biasing conditions. A PN junction diode can be connected either in forward bias or in reverse bias. So here, when we are talking about this photodiode, we are connecting it in reverse bias. Reverse bias means what? Take a PN junction diode. I am drawing the simplest of the diagrams to understand just the reverse bias. So P is connected to negative and N is connected to positive. So we see here, this is the external supply, positive, negative. So we have connected the P type of the PN junction to the negative and the N type of the junction to the positive. This is the external supply. So when it is connected in this manner, we say that the diode is connected in reverse bias. Now, the function of this photodiode is opposite to that of an LED. Opposite to that of an LED. So, what is opposite here? We are going to understand. In LED, what we have seen, photons are released in response to the current flow. Means when we take an LED and when you allow the current to flow through it, light is emitted or photons are released. So here photons are released. That is why we call it as light emitting diode. Light is being emitted. So it's a LED. But in photodiode, what do we observe? Photons are absorbed and it results in the generation of charge carriers which will manifest as current. Or if I have to put it simply, in an LED, if you take an LED, electrical energy, the external energy that we supply, electrical energy is getting converted into light energy. We need to understand the basic difference between an LED and a photodiode. So in LED, electrical energy is getting converted into light energy. This is in the form of photons. But when we take a photodiode, light energy, when light falls on the photodiode, this light energy is getting converted into electrical energy. This is getting converted to electrical energy. So this is the basic difference. This is how a photodiode is opposite to that of an LED, we are saying. So conversion of electrical energy to light energy in LED, and in photodiode it is the conversion of light energy to electrical energy. Now coming to the symbol. So whenever we draw a circuit, in the circuit, how do we represent a photodiode? So we have a symbol used to represent a photodiode. So the symbol for the photodiode is a triangle with a line, vertical line, and there are two arrows pointing towards the junction. What these two arrows represent here is light is incident on the junction. So when light falls on the junction, that is getting converted to electrical energy. So this side is always positive and this is negative. So we always say this is the terminal which is connected to the anode and this terminal is connected to the cathode. So this is the symbol. We always have to remember the symbol. If you see a normal PN junction diode, we are just talking about a junction diode or a PN junction diode. What is the symbol we have? A triangle with a line. So this is positive and this is negative. This is a PN junction diode. Now when it comes to LED, what we have seen, we have taken a PN junction diode and we have connected it in such a way, in a forward bias always we connect, and there are two arrows which are pointing outward. Outward always represents the emission of light. So these are the symbols we need to remember. A normal photodiode, a normal PN junction diode, and this is the LED where light is emitted, and this is the photodiode where light falls on the junction and that is getting converted into electrical energy. Now the principle of photodiode. It works on the principle of photoelectric effect. So this is the famous effect that was demonstrated by the scientist Einstein. He gave this photoelectric effect in the year 1970. So what photoelectric effect says is photo is always related to light. Again here light energy, how it is getting converted into electrical energy. Einstein very clearly explained the principle or the phenomena that occurs in the conversion of light energy to electrical energy. So photodiode also works on the principle of photoelectric effect. So the operating principle is such that when the junction of this two-terminal semiconductor device is illuminated, illuminated means when we say some light falls on the junction diode, it is illuminated. We are allowing some light to fall onto the junction diode. So we say it is illuminated. Means when light falls on the junction, then electric current starts flowing through it. So that is why we say that is converted into electrical energy. And here only minority current flows. When I say minority current is always due to minority charge carriers. It is due to minority charge carriers. So whenever we are taking a PN junction diode and connecting it in reverse bias and we are illuminating it, then what we are getting? We are getting current. And this current is very small, so we call it as minority current. And this minority current is due to the minority charge carriers. When we study the working, then we discuss about the working of the photodiode, we will understand what these minority charge carriers are. Now let us see the diagram or the cross-sectional view of the photodiode, and then we will understand step by step how this is constructed. So what we are seeing here is, we said it is a two-junction diode. So we have a p-type material and then we also have an n-type material. So P and N, which forms the p-n junction. So this is the p-n junction, how it is formed. And in a normal p-n junction, we have also seen how a depletion layer is formed. So how a depletion layer is formed? When you have a p-type and n-type material placed together by any means, by diffusion say, the electrons, which are the majority carriers in the N side, will diffuse onto the P side, and the holes that are there, which are the majority carriers on the P side, will diffuse onto the N side. So electrons from the N side will go on to P side, and holes from the P side will diffuse onto the N side. And as the process continues, what happens is, there are immobile ions, positive ions that are stuck to the crystal lattice on the N side, and there are negative ions that are stuck to the crystal lattice on the P side. And because of these immobile ions, this region will develop a potential, and we call it as potential barrier. There is an electric field that is developed, and this electric field will remove all the free charge carriers from this region, and we call this as depletion region. This region is called as depletion region. What do we understand by depletion region? Means a region which is depleted, which is free of all the charges. We call it as depletion region. Now there are no free charge carriers here. So because of that, there is a barrier that is formed. So what is the depletion layer here now? It is a region where there are no free charges, only immobile ions that are present. And then what we have here is a silicon nitride coating, which is the passive region, and then a silicon dioxide diffusion mask. So this is the diffusion mask here, and this is the silicon nitride coating. And then we have the contacts, one for the anode and the other for the cathode. This is for the cathode, anode and cathode. Okay, and this is the region near the junction where light will be incident. This is the region, I can say, where light is incident. Now let us understand the construction step by step. So the photodiode is made up of two layers of p-type and n-type. So we have seen two layers. This is p-type and this is n-type. So p-type material is formed by the diffusion of lightly doped p-type substrate. We will take an n-type material and on it we will place a p-type material and heat it to a very high temperature. Because of that, the p-type atoms will diffuse into the n-type. So a layer of p plus ions is formed due to the diffusion process. What is happening? There is a layer of p plus ions that are formed. Then an n-type epitaxial layer is grown on the n-type substrate. So you take an n-type substrate and then on that you will grow the n-type layer. So P plus diffusion layer is developed on the n-type heavily doped epitaxial layer. So the n-type is heavily doped and the contacts are made up of metals. So we have to have metal contacts to connect them to the terminals, cathode and anode. So we have seen the two terminals. This is the metal contact for the anode and this is the metal contact for the cathode. Now the front area the front side of the diode is divided into two types. What are the two types? The active surface area and the non-active surface. So what is the difference between active and non-active? Active surface means where light is incident, and non-active means where the light is not allowed to fall. So this non-active surface is made up of silicon dioxide, and the active surface is coated with anti-reflection coating. Means light should be absorbed, it should not be reflected back. So the active surface is always coated with anti-reflection material. Now this active surface is also called so because light rays are incident on it. So the region where the light rays are incident, we are calling it as active. So I can say this region is the active surface area. So while on a non-active surface, light does not strike. So no light is falling on the non-active surface, and that non-active surface is coated with anti-reflection material. So light should not fall on the active, non-active layer. So the active layer is coated with anti-reflection material, so that light energy is not lost. So in the active layer, it should absorb the energy, and that energy will get converted into the light electrical energy. So the maximum of it can be converted into current. Now the entire thing, whatever the construction we have seen, it is placed inside a glass material. Why we are placing it inside a glass material is to allow the light energy to pass through it. Because when you see glass is transparent and it allows the light to pass through it. So we are placing it in an entire thing, in an entire case. So as only the junction is exposed to radiation, the other portion of the glass material is painted black. So whatever region is exposed to light is there, but the other region we are painting it black. And if it comes to the size of the photodiode, it has very small dimension of the order of 2.5 millimeter. The size of the photodiode is very small. So it is around 2.5 millimeters. And also what we need to understand here is the current flowing through the device is in microampere. So what do you understand by microampere? 1 microampere is equal to 10 power minus 6 ampere. So small it is. So in the beginning itself we have discussed that the current flowing is minority current and it is due to minority charge carriers, and here we understand that it is in microamperes, that is 10 power minus 6 ampere. So because the current is very small, we use a microammeter because it is convenient to measure small currents. Instead of using an ammeter, we'll use a microammeter. Now coming to the operational modes of photodiode. What are the operational modes? It operates in two modes. The first one is the photovoltaic mode. First mode of operation is photovoltaic mode. So this photovoltaic mode is also known as zero bias mode. So what do you understand by zero bias? Means no external reverse potential is provided to the device. So without providing an external supply, when we are operating this photodiode, then you call it as zero bias mode or photovoltaic mode. And the flow is due to the minority carriers, and it will take place when the device is exposed to light. So we take a photodiode, connect it in such a way that the current falls, light falls on the junction, and this light, without connecting any external supply, you get current due to the minority carriers. So when it is exposed to light, we get current due to the minority carriers. The next one is the photoconductive mode. So what is this photoconductive mode? When a certain reverse potential is applied, means we are connecting the photodiode in reverse bias. Now we have already seen what is reverse bias. In photovoltaic mode, when the potential barrier is formed, we are not connecting any reverse bias. But here we are in photoconductive mode. We are connecting it in reverse bias. P connected to negative and N connected to positive. So what happens because of this reverse bias? The depletion width increases and it also varies with the change in reverse voltage. So as the reverse voltage goes on increasing, the width of the depletion layer also keeps on increasing. Now coming to the working principle. What is the principle on which it works? So when this diode is reverse biased, the depletion region starts expanding and current starts flowing due to minority charge carriers. So what we can understand here about the reverse bias is how the depletion layer width keeps on increasing. Let us try to understand this point about the width of the depletion layer. Okay, so what we have seen now is P, N, electrons are the majority carriers in N side, holes are the majority carriers in the P side, and because of the diffusion process, we are having positive immobile ions on the N side and we have the negative immobile ions on the P side, because of which there is a barrier that is formed and we will call it as the barrier potential. This is the barrier potential. And now when we are connecting it to the reverse bias, P connected to negative and N connected to positive. So when it is connected in reverse bias, these holes will get attracted towards the negative terminal of the external supply. All these holes will start moving towards the negative terminal and their electrons here, they start moving towards the positive side. So as more and more electrons move away from the junction, there are more and more positive ions that are being created. So the depletion layer width keeps on increasing. And on this side, what keeps on increasing? The negative immobile ions keeps on increasing. So the width of the depletion layer increases. This is how the width is increasing. So the depletion layer starts expanding, means the width increases. And with the increase in reverse voltage, the reverse current starts flowing. When you have applied the voltage and you keep on increasing the voltage, as the width increases, there will be more current. And the same condition can be obtained without applying the reverse bias also. So even in without applying the reverse voltage also, we can see the same phenomena. And in the photodiode, a very small reverse current flows through the diode and we call it as dark current. You need to understand this term dark current. What is this dark current? Dark current is the current due to the minority carriers when the junction is not exposed to light. Means there is no light, not exposed to radiation. Without exposing the PN junction diode to light, there is a very small current that is flowing due to the minority carriers, and that is what we call it as dark current. We will try to understand it when we see the characteristics also. So the electrons that are present in the P side and the holes that are present in the N side are minority carriers. So when electrons are the majority in the N side, holes will be the minority. And the same thing with the P side. When in P side, holes are the majority, so electrons will be the minority. So when reverse bias voltage is applied, holes from the inside experience repulsive force from the positive potential of the battery. Similarly, the electrons that are present in the p side experience repulsion from the negative potential of the battery. So because of these repulsive forces, what happens? The electrons and holes will recombine at the junction. So now what is happening at the junction? What we are trying to understand is, we have the junction PN. The depletion layer increased because of the reverse bias we have applied. Now what we are trying to understand is the minority carriers, which are the electrons here, and the minority carriers, which are the holes here, will try to cross or come across the junction. Then there will be recombination of electrons and holes. This is what we call it as recombination. Recombination of electrons and holes will occur at the depletion layer. So this combination of electron and hole will generate a neutral atom at the depletion. And due to this, what happens? The flow of current is restricted. Then what we do? We will illuminate the device with light. So now light is allowed to fall on the junction. So this is the junction where there is recombination that is occurring. Electron-hole pairs that are combining. And this is negative. Now at the junction, what we'll do? We'll allow the light to fall on the junction. So as light falls on the surface of the junction, temperature of the junction increases and electron and hole get separated from each other. So what happens here? Because of the light energy, these electron and hole pairs, they are getting separated. So when they separate, what happens? As the two get separated, electrons from the inside get attracted towards the positive terminal and the holes present in the p side get attracted towards the negative terminal. So there is movement of charge carriers which generates a high reverse current. So this is how we are seeing how light is getting converted into electrical energy, that is current. Because of the light energy, they are gaining the light energy, they are separating, and there is movement of electrons and holes across the junction, because of which we will get a high reverse current. And when the intensity of the light increases, means the amount of light that falls on the junction diode is increased, more and more charge carriers are generated. So there will be more charge carriers, more electrons and more holes, because of which there will be large current through the device. And this current is used to drive the circuits in the system. Also, what we can say is the intensity of light energy is directly proportional to the current. So more the intensity of light, more the current that is produced. So that is why we are saying, if I denote the intensity of light, it is directly proportional to the current. And the positive biased potential can put the device in no current. So when we are connecting it in forward bias, there will be no current because the width of the depletion layer goes on decreasing. That is why there will be no current. Now let us see the characteristics of photodiode. So what characteristics we are going to see is the voltage current characteristics. We call them as voltage current characteristics. Means what we are going to study here is, with the increase in voltage, how the current varies. That is what we are going to understand. So what we are doing now is, we will take voltage along the x-axis. So this is the positive x-axis, so plus V, and this is the negative x-axis, this is minus V. And we will take the current, we will take the positive current plus I along the positive y-axis and minus I along the negative y-axis. And because we are seeing this is reverse current, okay, we will be seeing it in the third quadrant. So this is the third quadrant we are observing. Now what we are plotting here is, we are keeping on increasing the reverse bias voltage. So as the reverse bias voltage increases, what happens to the current? That is what we are trying to understand. Now the first one, what we are seeing is dark current. What is dark current? It is a current due to the minority carriers when the photodiode is not exposed to light. Even before light falls on the photodiode, there is a small current which is flowing due to the minority carriers, and that we are calling it as dark current. So now this dark current, if you plot the characteristic, as the voltage increases, as the reverse voltage increases, the current increases. There is a small current which is almost constant. And now as we are increasing the reverse voltage and we'll allow the light to fall on it. So what is happening, you see here, there is a slight increase and then it becomes saturated like this. So for different currents we are plotting the graph. We are varying the voltage and we are plotting the graph. And what we have also seen, that as the intensity of light increases, the current also increases. So these are the characteristics curves of a photodiode. And here I said, because the current is small, we are using a microampere. We are expressing it in microampere. So what the vertical line represents is the reverse current, and what the horizontal line represents is the reverse bias. So this is the horizontal line. It represents the reverse biased potential V. And this is the vertical line. What the vertical line represents is the reverse current. And the first curve is representing the dark current. So this curve represents the dark current, which is due to the minority carriers. And then in the figure, what we are seeing, there is almost equal spacing between these curves. What this shows is current proportionally increases with the luminous flux. Means as the intensity of light increases, the current increases, and they are directly proportional. Now coming to the advantages of photodiode. What are the advantages of photodiode? So it shows a quick response. Quick response in the sense, as soon as the light falls on the photodiode, you get the current. Okay, so the response is very quick. And photodiode also operates high operational speed. The speed at which it operates is also very high, and the response is linear. Okay, linear, you say ki as the voltage increases, the current increases. So it has better stability. Stability is also good. And greater dynamic range. The range is also very high, and it's a low cost device. The cost is also very less. So all these are the advantages of a photodiode. Now coming to the disadvantages. What are the disadvantages here? It is a temperature dependent device, and it shows poor temperature stability. So as the temperature varies, what is happening here? The current also varies. So it has very poor temperature stability. And when no illumination, low illumination is provided, then amplification is necessary. When the illumination is very less, means when the amount of light falling on the thing is very less. So you need amplification to see the current. And then coming to the applications of photodiode. So photodiodes majorly, they find its use in counters and switching circuits. Wherever we are using counters and switching circuits, we use photodiode. Okay. And photodiodes are also extensively used in communication system, especially the optical communication system. When I say communication systems and when we are using optical fibers, so in an optical fiber where light is used as the carrier for the signal, we need to convert the light energy into electrical energy. So especially in those areas where you need to convert a light signal into an electrical signal, we use photodiodes. And also, they are used in logic circuits and encoders. So, encoding and decoding also we do in communication system. So, they are used in logic circuits also and encoders also. Then it is widely used in burglar alarm. It is used in burglar alarm systems. What are these alarm systems? You can see here the basic circuit for a burglar alarm. So, in a burglar alarm, what we have is a photodiode. This is the photodiode which is connected in reverse bias. We connect this photodiode in reverse bias. And then this is a circuit, you will have some fixed resistances to limit the current flowing. And there is an amplifier also, and it is connected to a buzzer. So, burglary, wherever we have valuables, no, like in banks and where we keep lockers and all, they have to be protected. So, there we'll be using the burglar alarm. So, what happens here is wherever the device is there will be a photodiode and light continuously falls onto the photodiode. So, as long as the photodiode is exposed to light, there will be current flowing. Means continuously there is conversion of this light energy to electrical energy. So, the circuit is complete and current flows. And the moment somebody enters inside and this light is cut off, the light that is falling on the photodiode is cut off, then what happens? There is no current. So, whenever there is no current, the alarm goes on. So, what we are seeing here? Until the exposure to radiation is not interrupted, means there is continuous supply of light onto the photodiode, the current will flow. And when the light energy fails, when will the light energy fail? When somebody comes inside and interrupts, the light will fail and it will not fall onto the device, and because of which the current is cut. And when there is no current, it sounds the alarm. That is how it is widely used in burglar alarms. Now, for referring to this topic, for the basics of whatever we have seen about the photodiode and the PN junction, you can refer to Semiconductor Physics and Devices by Donald A. Nieman. And in detail about the photodiode, you can refer to Semiconductor Devices, Physics and Technology by Simon Z. and Mingwin Lee. So, these are the two books you can refer for clarifications regarding any topic or further knowledge about the topic. Thank you and see you.
Like, share and subscribe. Hit the bell icon for more updates.